All right, so it's Tuesday, 9/12, day before the test. This is the first period video where I will do 1, 4, 7, 10, etc. All right, number one. I think I've already told you the free response question at the end of the test is very similar to this opening set here, where I give you a table and then ask for a whole bunch of different things. H prime at 2 if h of x equals g over f. Okay, so quotient rule, except that g and f are backwards from how we remember the quotient rule. So the usual quotient rule is gf prime minus fg prime over g squared. But this is backwards because we switched the g and the f just to mess with you and see if you can keep up with things. So normally it's f over g. So let's see if I can figure this out. So instead of gf prime, it should be fg prime, because things are backwards, minus gf prime all over the bottom one squared. Bottom times derivative of the top, bottom times derivative of the top, minus top times derivative of the bottom over bottom squared. Okay, I feel good about that one now. So, got to really slow it down when they try to mess you up like that. So then I want to evaluate all of those at x equals 2. So f at 2 is 3. G prime at 2 is negative 1. Nope, is 1. Excuse me. Minus g of 2 is 6. F prime at 2 is negative 4. All over f at 2 squared. Wow, you can use the table 5 different times. So 3 plus 24 over 9. 27 divided by 9 is 3. There it is. I mean, that should be a pretty straightforward problem. Like just a straightforward application of the quotient rule and using the table. Number 4. H prime at 3 if h equals g of 2x. So what rule are we thinking about here if we're going to take the derivative of g of 2x? What rule is that going to be? Chain rule. So outside in, the derivative of g is g prime. And I think most errors are going to happen when people stop right there. But they've not chained it all the way. What else do I need to include on this? The derivative of 2x would be times 2. So h prime at 3 means plug 3 in for x. So I need g prime at 6. Go to the table. G prime at 6 is negative e, and then times 2, so negative 2e. Again, on those table problems, there's not really much in terms of computation. It's just very straightforward. How well do you know the product quotient chain rules? Number 7. Still referring to the table, use the equation of the line tangent to the graph at the point when x equals 2 to approximate the value of f of 2.5. So I need to find the equation of the tangent line, which means I need a point and a slope. And then I'll use that tangent line and plug in 2.5 and see what I get. So the tangent line to f, the point I'll use is 2 comma something, and the slope means f prime. Okay, 2 comma what? What's my y coordinate of the f function? Look in the table. What's the y coordinate when x is 2? 3. And f prime when x is 2 is negative 4. Again, just looking at the table. So my tangent line, y minus 3 equals negative 4 times x minus 2. But I want to use that to estimate f of 2.5. So I'm going to move the 3 over and then plug in 2.5. So f of 2.5 estimated approximately. So this isn't the function at 2.5, it's the tangent line at 2.5, which should be close to the function. And I'm going to safe stop this thing by plugging in 2.5 and calling it a day. So lots of steps in number 7, and lots of reading and understanding what they're asking. The process wasn't really that hard, but understanding what they were asking might have been the trick. All right, number 10. Someone asked about number 10 earlier. Oof. X times natural log of that ugly thing. So already I'm thinking product rule. And then within that, I want to break that up. I don't want to mess with that as it is. So natural log of cube root of x minus natural log of e to the x. All right, I've got some algebra stuff to do before I think about derivatives. The cube root, that's the same thing as a power of 1/3. So that's nice. Nicer anyway. How about natural log of e to the x? What's that equal to? Good, just x. Because this is one of those places where I can take the x down front. And then the natural log of e is 1. Okay, I still have a decision to make. I can take a derivative on that, or I could distribute the x and then take the derivative. Shouldn't matter, but I think it would be easier if I distributed the x first. 1/3 x ln x minus x squared. So by distributing, I didn't get rid of the product rule. I'll still need to use it here, but I think using it on this is easier than using it on this whole thing. Okay, so 1/3. Now the product rule is first times derivative of the second. I'm just going to leave the 1/3 out front. Plus derivative of the first times the second. And then a very frustrating but common mistake on these type problems is to stop there. Like you got so focused on the product rule, what else do we need to do? Like I did the product rule right, but why is my answer not complete? What's left? That x squared. And so it's a silly mistake, but it's kind of an understandable mistake. You get so focused on doing some complicated rule the right way that you forget about taking the derivative of the rest of the problem. All right, none of my answers look like that, but the x's cancel, so that's 1/3 plus 1/3 natural log x minus 2x. Does anything look like that? Let's see. Nothing looks exactly like that. But if I distributed this 1/3 on this first answer choice, then I think that's what I would get. So that's another problem where algebra, 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 calculus, algebra, and then to find the right answer was algebra. Again, the hardest part of calculus is the first 12 years, right? Like, calculus wasn't bad, it was all the other stuff for that problem. Again, multiple choice or partial credit is available on multiple choice, but I need to see what you're doing, and that includes labeling what you're doing. If you don't label it, if you just start writing stuff down, which is some of the habit of some of you guys, then I don't know when you thought you were taking a derivative and when you were just doing algebra. So if you label it, then I can keep up with what was going on and maybe give some partial credit if I can, basically it comes down to this. If I can easily locate your mistake and it's a minor mistake, then you get partial credit. If I can't find what you did wrong fairly quickly, then no partial credit. Or if I can find what you did wrong and it was, abysmal, then no partial credit either. So the key to getting partial credit is show your work nice and neat so I can find it and hopefully make a minor mistake that's worth some points. All right, that was number 10. Number 13, find dy dx. Oh, another algebra problem, right? I don't want to take the derivative of that thing as it is. I could. It'd be 1 over all of that, and then times the quotient rule. No, thank you. Let's do some algebra first. So natural log e to the x minus natural log e to the 2x plus 1. And, well, hey, one more algebra step. X can come down front. And I'm tagging on equal signs, which is fine because they're all attached to that y equals. Now I'm done with algebra. Now I want a y prime. So derivative of x is 1. Derivative of natural log is 1 over the argument times the derivative of the argument. So that would be e to the 2x times 2. Okay, so 1 minus 2e to the 2x over e to the 2x plus 1. And of course that's not any of my answer choices. D is kind of close, but there's an x there, which means this must be a common denominator add fractions type problem. So the first fraction needs an e to the 2x plus 1. Second fraction is good. Okay, so e minus 2e, so that's negative e to the 2x plus 1 over my denominator. Okay, so I wrote it in backwards order, or not backwards as in wrong, just different order. But that matches answer choice B. And yet another problem that is algebra, algebra, calculus, algebra, algebra, algebra. Number 16, table problem. An inverse table problem though. Selected values of g and g prime are given in the table. What is the equation of the line tangent to the graph of the inverse where x is 2? Okay, well I think I need to make my own table here. G and g inverse, point and derivative. Tables all over the place. The main point of my table is that those two things are reciprocals. Let's see. To write a tangent line, I need a point and a slope. And so actually I need both of these. I need this column or that cell for a point, and I need this spot for my slope, and then I can write the equation of the tangent line. Alright, so it tells me x equals negative 2. Is that for the inverse or for the original? It's for the inverse, because the graph of the inverse when x is negative 2. So negative 2 is the x value for the inverse of g. Alright, that gets me started. So what else does that mean? Where else can I use that negative 2? It's the y for g. And how does that help me? Because then I can find the x that goes with that y. So what x value gives me a y value of negative 2? Right, 5 negative 2, so that's a 5, which means this is a 5. And then I want the derivative of g at 5, the derivative of g at 5 is e, and so my slope is 1 over e. Okay, so now I've got my point, negative 2, 5, and my slope is 1 over e, and I'm not even going to write it because now I look at my answer choices and they're all in the right format. So it should be y minus 5 equals 1 over e. Oops, not negative 1 over e. 1 over e times x plus 2. So answer choice C. Slow down on those inverses. Take your time. Put everything in the right spot. Don't try to answer those questions without doing the table. Number 19. Limit as x approaches 0. Okay, if I plug in 0, I get 5 to the 0 is 1. 1 minus 1 over 0. That's 0 over 0. That doesn't work. So, what can I do? Can't factor out anything. I need to check and see. So we can skip 19 because it's an easy problem. It's an easy problem if you know what to do, but we hadn't gone over what to do. So skip 19. We'll come back to that. It's like this standalone lesson that you can kind of stick anywhere, and we hadn't stuck it in yet. So pass on 19. And again, there's not one on the test that's like that, so we don't have to worry about it yet. And then number 22. If y equals e to the x cubed, find the second derivative. Again, there's no magic to finding a second derivative. You can't get there without finding the first derivative. So let's find the first derivative. So that would be e to the x cubed times 3x squared. Now I need a second derivative. I wonder if that's one of my answer choices. Nope. What's it going to take to find the second derivative? What rule is going to be involved here? Product rule. So without even doing anything, I bet my answer is C or D because that looks like the result of a product rule. So I'm guessing it's C or D. Let's see. Okay, so first times derivative of the second. E to the x cubed times 3x squared. Plus second times derivative of the first, just be 6x. Okay, I like the 6x on both of those, but that's not enough. If I factor out e to the x cubed, that gets me 9x to the fourth plus 6x. So answer choice D. So again, I knew it was C or D because the product rule was involved, and then the details got me to choice D. Alright, so that's a third of it. Again, the other thirds will come later.